Dear students, today we are going to discuss the 15th session of Graph Theory 2 of the first unit. In this session, we are going to discuss some applications of these graphs, that too in electric networks. Okay, so how the graph theoretic ideas, especially the Eulerian graphs and Hamiltonian graphs, are used. Okay, so that we are going to discuss in this session. Already, you know, the Eulerian graphs and Hamiltonian graphs are used to solve physical problems. Already we have discussed. One is the traveling salesman problem. To solve a traveling salesman problem, we need to find out a Hamiltonian cycle. Of course, there are different Hamiltonian cycles. In that, a Hamiltonian cycle with minimum weight is considered as a best route to travel in that fashion. Okay, so that could be the solution for the traveling salesman problem. So with the help of Hamiltonian graph, and later on we took one application, that is the Chinese postman problem. To solve the Chinese postman problem, we need to find out Eulerian cycle, or you can say the closed walk, which involves all the edges with a minimum weight again there also. So that is the application of Eulerian graphs to solve the Chinese postman problem. So now here some more applications if we consider. Of course, electric networks, especially computer systems. Okay, so in the computer systems, you know, the designs of computer systems have several modules and several pins at each module. Okay, you know already all these things. The designs of computer systems have several modules and several pins at each module. We predetermine the physical position of each module. We wish to interconnect a given subset of pins by wires, subject to the following conditions. First condition is, at most two wires are to be attached to each pin. And the second condition is, the total length should be minimized. Okay, so with these two conditions, this situation can be modeled by a weighted complete graph. You know already what is weighted graph. Again, edge is given a real number, weight is given. Okay, so here length of the wire is considered. Okay, so complete graph, you know, complete graph. What do you mean by complete graph? In which every pair of vertices are adjacent. So this situation can be modeled by a weighted complete graph G, in which the vertices of G corresponds to the given set of pins, labeled 1, 2 and so on and so forth P. The weight Wij, that is joining the Pi and Pj pin. Pi is one pin, Pj is another pin. If you join Pi and Pj, you will get an edge. So that edge will be Wij, and the weight of that edge is considered as Wij. The edge joining Pi and Pj, the weight of that edge is nothing but Wij. Of an edge joining the pin I and pin J in the actual distance between pin I and pin J. Okay, now condition 1 states that we find a Hamiltonian path in G. Here condition 1 states that we find a Hamiltonian path in G. What do you mean by Hamiltonian path? Starting point is different, ending point is different, but it contains all the vertices of the graph. It implies here also you are starting with one pin, you have to end with another pin, but all pins must be considered in this path. Okay, every vertex is considered once. It implies every pin must be considered once. Okay, so that is the condition. And the condition 2 specifies that such a path must have a minimum length. Of course, there are different paths if you consider, but they should be a path must have minimum length. So if we introduce a dummy pin labeled 0 and let Wij equal to 0 for some I, 1 is less than or equal to I is less than or equal to P, then the wiring problem becomes, here we are wiring, you are joining the pins by wire, then the wiring problem becomes a P plus 1 city traveling salesman problem. So it will be the same as P plus 1 city traveling salesman problem, because for initially we have considered P vertices. After that you are adding one more dummy pin you are introducing. It implies you are getting a closed path, that is Hamiltonian cycle. So that could be P plus 1 city traveling salesman problem. So this is how, these are the some applications we have given. Okay, so as far as the theory is concerned, just we have given a brief introduction about the application part, but in detail, if you want, if you are interested to go through some application part of these Eulerian Hamiltonian graphs, you may refer a textbook of graph theory by Narsingh Dev. Okay, because of the stipulated time allotted to these sessions, so we have given a brief introduction or brief ideas how the graph concepts, that especially the Eulerian and Hamiltonian graphs, are used to solve some real life problems. Okay, so with this we conclude this session. So before concluding, what we have discussed in this session, in this session we have discussed some application part, especially the computer systems. Okay, that is, there are some pins and we are joining all the pins by wires. So in that, the starting pin and the last pin, that is the all pins must be considered in that circuit, you can say, with a minimum length of wire. Okay, so this is how we have discussed in this session. So therefore, these are the books which I have referred. One is Graph Theory by Frank Harari, Narosa Publishing House, New Delhi. Or if you want, you can refer Graph Theory by Professor V.R. Kwedi, Viswa International Publications, Gulbarga. This is as per the old syllabus of Gulbarga University, Gulbarga. If you want, you can refer Graph Theory by Professor V.R. Kwedi. Thank you.